Hello everyone. In this video I am going to give you a brief introduction to calculus and in detailed study of functions. So here, what is calculus? Calculus is a Latin word which means small pebble. In early 17th centuries there were no calculators or some other devices which were not there. So these small pebbles were used for doing calculations. So who is the founder of calculus? These two mathematicians, Newton and Gottfried Leibniz, separately invented calculus. Okay, what is the other subject? Geometry, which deals with the study of shapes, and probability is a branch of math which deals with study of chances. Okay, the calculus deals with study of changes or rate of change. So what type of rate of change? Rate of change of one variable with respect to another variable, like rate of change of y with respect to x, okay, like that. So consider slope graph like this, okay. In this graph, finding slope is very easy. You see, it is just a rise over run. Obviously it is easy, but finding slope in this graph is a tough task. Okay, so consider this graph. There is some arbitrary function f of x is equal to y. Okay, so here what is slope of this function? Here we have to consider slope of this curve. Oh, what is slope of this curve? Slope of curve means a curve. In this curve, let us say, what actually is slope of this line? It is m is equal to f of x plus h y coordinate at this is f of x plus h minus f of x, okay, divided by h, this distance, okay, h it is. This is slope of this line. So here this is very inaccurate. This slope is very inaccurate. But to make it very near to the value, if we make this h is equal to 0, means this distance equal to 0, it becomes infinity, does not exist. So here is a problem. If this slope, okay, if these point, if they meet, then there is a problem. If they come very close together like this, here very close together, means this distance approaches 0 from either side. H approaches near to 0, means like consider h is equal to 0.000001. As it approaches 0, then the distance between these 2 points reduces. Obviously there will be accuracy of high level. There will be high level accuracy. So in this way, the calculus tells us we have to make this h not equal to 0 but nearly equal to 0, means like this. At this point, h is equal to 0.00001, we get very high level accuracy of this slope. So by this secant becomes almost equal to tangent, okay, like this secant, okay, as this distance becomes 0, then this just touches, okay, just touches the curve at only one point, which there exists slope of this curve at x. Consider this as x. There exists f dash of x. Later I am going to tell you this in next video. F dash of x, okay. This is the main idea of calculus, okay. So next, what is the function? This is pre-calculus, okay. Pre-calculus. What actually is function is function, okay. Function. Consider in what is function? Let's say rice mill, okay. Sorry, like a flour mill. In flour mill, if you put rice, it will give rice flour as an output, okay. Wheat, if you put wheat flour as output, okay. So what is the function here? So here function is, it is just decreasing the size of the grain of whatever you give rice. It is reduced size of grain, okay. Wheat, reduced size of grain, wheat flour, okay. Here, as the distance between these two grinding wheels decreases, okay, x decreases, the accuracy of getting output increases. As it increases, accuracy decreases. Likewise, this is the best example for function, okay. In this way, this rice is independent variable, okay. This is dependent, what is rice flour is dependent on this wheels and distance between wheels. F of this is x, this is independent variable. If you give it to the function, then it will give f of x. This is dependent. This dependent variable is dependent on this, okay. So again, this is the general day-to-day life example for function, okay. So let's see what mathematically the function is. A function from set T to set E, or consider any alphabets, okay, is a rule that assigns a unique value f of x, that is function in y, to each and every element in x. Each and every element in x means this domain, each in domain D. Domain means okay, like consider this function f of these are x values 1, 2, 3. They map down to 4, 5, 6. Here if you give 1 as input, we get 4 as output, 2 as input, 5 as output. Like this. This is domain, this is range, okay? Domain is all possible inputs. Remember, domain, what do you mean by domain? What are all the possible input values we can give to a function? Inputs, okay? Inputs. To get what? Range. All possible outputs. So we get all possible outputs by using function, okay? So here what is domain? Domain means like consider function f of x is equal to x square, okay? So here what inputs we can give? We can give all the real numbers from negative infinity to positive infinity, okay? What are all the outputs? This is domain, we represent like this. What are all the outputs? They are in range, okay? They are only positive integers. We get only positive integers, positive real numbers. These real numbers, okay? Only positive real numbers. 0, close interval 0 to positive infinity, okay? Real numbers. Whatever you give from real numbers, you will take, but we get output as positive numbers from 0, okay? Like consider another function f of x is equal to root x. Here it is a bit tricky, okay? In this, what is the input? That is domain. It is from 0 to only positive real numbers, because negative real numbers, it doesn't exist there. The output doesn't exist. But we can give only positive real numbers, okay? What output we get? All output we get is range, that is from 0 to infinity, positive infinity. This is the domain and range. I'm going to discuss some more problems in the next video and in detailed study of functions. And next we deal with how to graph the function, how to represent a function, okay? Functions are represented in 4 ways, like consider function representation of function, functions, okay? Functions can be represented in 4 ways. First one, by equations, okay? equations like f of x is equal to x square, f of x is equal to x square plus 1, f of x is equal to x square minus 1 by x cube. Like this we can represent functions. Okay, this is one type function. Second one, graphically we represent function like this, like consider this function x square. Okay, this is x square and this is y. Okay, like f of x is equal to root x, f of x is equal to x cube, in this way we can represent function graphically. Okay, numerical methods like numerically by conducting experiments. Okay, by conducting experiments we get some values. For those values we represent function like this. This is some experiment. For this we get values. We can represent function like this. Okay, in this way, fourth way, that is piecewise function, like f of x is equal to, consider f of x is equal to x at interval x greater than or equal to 0, root x for x lesser than 0. Sorry, x square, make it as x square because root x doesn't exist for less than 0. This is type of function. Another, let's say another, f of x is equal to mod x, means for all positive numbers, positive real numbers, and 1 by x, x lesser than 0. In this way, in these four ways we can represent functions. Okay, this is it for today's episode. Then we're going to deal with other topics of calculus. This is just introduction. Today I gave introduction to calculus and pre-calculus also, that is functions and representation of graphs. Okay, and finding domain and range. We do some more problems in the next episode. So please share this video and subscribe to my channel. And if you enjoy this video, then hit the like button. Okay, thank you.